The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope you all are doing good in your house. First of all, I would like to appreciate all the students in the class for sincerely writing your revision test and submitting it before time. That's it. When I was planning to conduct the test, I was not pretty sure that children will be ready to do it, but I am so happy because some of them, they called and they said, thank you teacher, like this is giving us more encouragement to study. So I am so happy and we would like to continue this again, because the next Sunday, as I have planned, we will be having chapter 3 and 4, only the theory part. Okay. And I could also find out where the children are making the mistakes, and I am so happy with that, you are now on with the syllabus, that is the portions, and also with the revision that is happening simultaneously. Okay. And now we will begin the class for today. That is a new chapter, P block elements. This we have learnt in our +1. The two haunting chapters in chemistry, +1, you remember children, S block and P block. You used to just wander up with the reactions, teacher how to remember, how to memorize the equations. So anything that is difficult, if you study with passion or interest, definitely you will learn children. You try to love the subject, learn it sincerely, definitely you will not forget it. Okay. So we will begin the new chapter, P block elements. Now P block elements, we know the group starts from group 13 to group 18, right, and we know 18th group elements are called as noble gases, or we will also call them as rare gases. But here for this year, in 15th group elements, we are going to see, that is in P block we are going to see group 15, 16, 17 and 18. These are the 4 groups which we will be studying this year. In 15th group elements, we are going to study about nitrogen, phosphorus mainly. The other things not that much in interest, but the properties and the behavior that will be followed throughout the group when we go down the group. So in 15th group elements, we have nitrogen, phosphorus, arsenic, antimony and bismuth. These are the 5 main elements in the group 15 of the P block element in the periodic table. So if you see nitrogen having atomic number 7, phosphorus with 15, arsenic 33, antimony 51 and bismuth with 83. And what happens, especially when you see the physical property, actually nitrogen and phosphorus will be behaving as non-metals. Arsenic and antimony will be behaving as metalloids, showing both metallic and non-metallic character, and bismuth will be acting as a pure metal. So this is the general trend, or I would rather say the non-metallic character decreases and the metallic character increases when we go down the group with the 15th group elements. Occurrence means we know how this 15th group elements occur basically in the nature. I will be sharing a small video as well for you to know about 15th group elements. See, nitrogen, basically we know 78% of the earth's atmosphere composed of nitrogen, and also you know its importance in the fertilizer and also for the growth of plants, nitrogen fixation bacteria, leguminous plants, you would have studied in biology. So nitrogen is very important for the growth of plants as well. Phosphorus most probably in the mineral content. Arsenic, antimony and bismuth you will find mostly in sulfide minerals. If you see the electronic configuration, because we started writing subshell electronic configuration, right. The outermost configuration for p block elements will be Ns2Np3, where the S subshell will be completely filled, because we know S subshell can take up only 2 electrons to the maximum. So, we have Ns2, 2 electrons completely filled, and Np3 where my p subshell can take actually to the maximum of 6 electrons, but it will be half filled. And we also learned that half filled or full filled subshells are more stable. So, this is giving an Ns2Np3, S subshell being full filled and p subshell being half filled. Atomic radii. What is atomic radii? The distance of the outermost electron to the nucleus. If I say it increases down the group, because we know in general atomic number also increases down the group. So, the number of shells also increases when you go down the group. Therefore, the distance between the nucleus and the outermost electron will be very far. So, what happens? Naturally, the atomic radius, or I would say the ionic radius or the covalent radius, it increases down the group. What is ionization energy or enthalpy? See, we know children, the electron present in the outermost shell can be removed. So, the energy required to remove the outermost electron from an isolated gaseous atom is called as ionization energy. Now, why do we say it decreases down the group? It decreases down the group because when we go down the group, the electron is far away from the nucleus. So, the attraction of the nucleus to the electron becomes less and less when we go down the group. The nucleus will not attract the electron towards itself. Nucleus being positively charged, it has to pull the electron being negatively charged. But when we go down the group, the electron becomes far away from the nucleus. So, what happens? Since the attraction is very less, you need very less energy to remove the electron from the outermost shell. Though the ionization energy decreases down the group, compared to the 14th group, it increases. 14th group is just before our 15th group. When you compare to the 14th group, it is a little bit more, the ionization energy. Now, electronegativity, we know tendency to gain the electron. Electronegativity also decreases down the group when you go to 15th group elements. Physical properties we have already discussed about metals, metalloids and non-metals. Chemical property. When we are studying about chemical property, basically we will be studying in detail about the reactivity of the 15th group elements with other elements like other atoms like hydrogen, oxygen, chlorine, all those things we will be studying now. Okay. The most important we should remember is the oxidation state. If you see, they can lose these 3 electrons or they can lose totally 5 electrons. So, the maximum oxidation state is -3, +3 or +5. These 3 are the basic oxidation state of group 15 elements, but nitrogen can have an oxidation state of +1 to +4, because nitrogen, if you see, it is Ns2Np1. So, what happens? It can take maximum Ns2Np2. So, it can take maximum, it can lose 4 electrons from the outermost shell. So, that is why we say nitrogen has got an anomalous behavior when compared to the other elements of the 15th group. So, which we will be studying now, anomalous behavior of nitrogen. If you remember, we have studied this already in +1, anomalous behavior of lithium. Children, you just recollect what we have learnt, basically depending on the electronegativity and the size of the element. So, which we will be discussing now about the anomalous behavior of nitrogen. So, what could be the reason that anomalous behavior is shown by nitrogen, or nitrogen has got an exceptional behavior compared to other elements of its own group? First point is because of its small size. Nitrogen having a very small size compared to the other elements, and because of its high electronegativity, because we know electronegativity decreases down the group. So, nitrogen will definitely be possessing a very high electronegativity. Also, it has a high ionization enthalpy compared to the other elements, and the most important is non-availability of d orbitals. Compared to the other heavy elements or higher atomic number elements of its same group, nitrogen do not possess d orbitals. It has only till the p subshell. P pi bond is possible only in nitrogen as compared to the other elements in the periodic table. Nitrogen is capable, though it is being a diatomic element, it is capable of forming a triple bond N, and so the bond enthalpy is very high, because we know a single bond, double bond and triple bond, the bond enthalpy becomes more and more as the number of bond increases between the same elements. But this nitrogen single bond is weaker as compared to that of the phosphorus single bond. The only reason is because of the interionic repulsion, that is the electronic repulsion between the electrons in the atom of nitrogen as compared to that of phosphorus. But in phosphorus also d pi p pi can be possible, but in nitrogen it is not possible. So these are some of the reasons for the anomalous behavior of nitrogen. Now we will just learn about the chemical properties of the p block elements, that is group 15.
Properties of group 15 elements. Look at these examples from your everyday life. Do you recognize the role of some elements in them? The freshness of frozen peas is preserved by the nitrogen that is used as a refrigerant in the freezer. The sparkling effect of firecrackers is due to the presence of phosphorus in them. Arsenic and antimony are used in the manufacture of solder alloys. Cosmetics like lipsticks and eyeshadows contain bismuth in them. There is something common in all these elements. They belong to group 15 of the periodic table. The elements of group 15 have some important properties that help them make important contributions to everyday life. Let us revise some of their properties with some practice questions. The elements of group 15 show varied properties related to their metallic character. Identify the elements of group 15 that are non-metals. Select the correct options and click Submit. Group 15 elements show a stable electronic configuration. Select the option that best explains the stable electronic configuration of group 15 elements. Select the correct option and click Submit. The ionic radius of group 15 elements increases down the group. What is the reason for this behavior? Choose the correct option and click Submit. Now let's look at the relationship between ionization enthalpy and atomic size. Choose the option that best describes what happens to ionization enthalpy with increase in atomic size from nitrogen to bismuth. Select the correct option and click Submit. Electronegativity is another important property. Which of the following is the reason for the decrease in electronegativity of group 15 elements from nitrogen to bismuth? Select the correct option and click Submit. Now let's see how much you know about the structure of nitrogen. Which of these options best describes the structure of nitrogen? Select the correct option and click Submit. Group 15 elements have a tendency to react with some elements. Select them from the given list of options. Select the correct options and click Submit. Read the statement and choose if it's true or false. The heavier elements of group 15 do not exhibit pi bonds formed by the overlap of p orbitals. Select the correct option and click Submit. Group 15 elements react with oxygen to produce some type of compounds. Select the correct option and click Submit. Nitrogen is a group 15 element that does not form a pentahalide. Choose the option that best describes why. The boiling points of group 15 elements exhibit a particular trend. What is it? Select the correct option and click Submit. The melting points of group 15 elements exhibit a particular trend. What is it? Select the correct option and click Submit. Now let's summarize the common trends observed in the properties of the group 15 elements.
We will learn about some of the chemical properties of 15th group elements. First is reactivity towards hydrogen. So any p block element can react with hydrogen to form hydrides. Now these hydrides, their stability will decrease down the group, which means ammonia will be the most stable, then the stability will be decreased once you go down the group, and bismuth hydride will be the least stable compared to ammonia. So as the stability decreases of the hydrides, their reducing character will increase, which means ammonia will be the mild reducing agent and the least stable bismuth hydride will be the strong reducing agent. So you should remember children, the stability will decrease down the group. As the stability decreases, the reducing character will increase down the group. So as the reducing character increase, now what will happen? The basicity will decrease, which means ammonia will be more basic in nature compared to the other hydrides and the 15th group elements. So ammonia will be more basic, the mild reducing agent and the most stable. So these are the things you should remember with respect to hydrides or reactivity of 15th group elements with hydrogen. Now the next reaction is with oxygen. Now with oxygen, 15th group elements can form two type of oxides, trioxides and pentoxide. The higher oxidation state, oxides of higher oxidation state will be more stable. So as the stability increases, what happens? The acidic character will decrease down the group. So what you will understand from this, as the acidic character decrease down the group, the elements at the top will be more acidic. That's it. Nitrogen and phosphorus will be purely acidic in nature. Arsenic and antimony will be amphoteric, means which have both acidic and basic character, and bismuth will be purely basic. See, these can come in 1 mark question children. So that's why I am just pointing out the bullet points here. So please copy it so that you don't forget. In the textbook you go vague because you don't know where you have to find out the important things. That's why I am writing separately in the blackboard. Reactions we have with respect to the 15th group elements, the reactivity with halogens. If you see, the 15th group elements can form trihalides and pentahalides with halogens. So when I say halogens, it can be chlorine, fluorine, bromine, iodine. Okay, the 17th group elements are called as halogens. So nitrogen cannot form pentahalide. What could be the reason? Because we have studied already that it does not have a vacant d orbitals. So absence of d orbitals will not make nitrogen capable of forming pentahalides. So nitrogen can form only trihalides. But the pentahalides, if you see, as compared to trihalides, they are more covalent. What is the reason for the covalent nature of the pentahalides? If you see, the central atom will have a higher oxidation state as compared to that of the trihalide. So here EX5, the oxidation state is more as compared to EX3, and it also has more polarizing power. We know what is polarization, attracting the opposite charge. So here it is more as compared to that of the trihalide. So that's why we say pentahalides are more covalent than the trihalides. These two questions are frequently asked in your board exam. So please remember children, one is nitrogen do not form pentahalides due to absence of d orbitals. Then why pentahalides are more covalent than the trihalides? Because of higher oxidation state and the polarizing character. All the trihalides except nitrogen are stable. When I say PH3, BiH3, all BiCl3, all are stable. We have phosphorus trichloride and phosphorus pentachloride. All these are more stable except our nitrogen. Nitrogen's trihalide only with fluorine is stable. Otherwise, all the trihalides of nitrogen are unstable. Now, when you see the reaction with metals, these 15th group elements form binary compounds with -3 oxidation state. They form binary compounds with -3 oxidation state. You have calcium nitride here, calcium phosphide, here it is zinc antimonide. So these are some of the examples which I have given. If you see, the oxidation state of the 15th group elements are -3. So these are some of the reactions which you should remember with chemical properties of 15th group elements. Now let us learn about dinitrogen. You will see a small video with respect to preparation of dinitrogen, then I will get back to the reactions.
Dinitrogen. What is special about nitrogen? A lot of biomolecules contain nitrogen as a key element. Nitrogen as a gas, when kept under pressure, attains extremely low temperatures. Liquid nitrogen is used as a coolant in preservation of food materials and biological samples. It's also used in cryotherapy to remove skin abnormalities and is very effective for topical surgical treatments. Molecular nitrogen or dinitrogen makes up 78% of the volume of the atmosphere. Every liter of air contains approximately 780 ml of nitrogen gas. Nitrogen is the 7th most abundant element in the universe and the 4th most abundant element in the human body. Nitrogen was first experimentally isolated by Rutherford and Lavoisier, named it azote as it did not support life. Nitrogen gas is inert because of the strong triple bond between the two atoms. Nitrogen atoms dissociate and react at very high temperatures only. Chemical nitrogen is obtained from reactions involving nitrogenous compounds, while atmospheric nitrogen is obtained from the air. Let's see how nitrogen is prepared in the laboratory and industrially. In the laboratory, dinitrogen is prepared by heating a mixture of ammonium chloride and sodium nitrite. Ammonium nitrite is formed, which when heated produces nitrogen. Nitrogen is collected by downward displacement of water in a gas jar. Nitrogen gas is evolved when chlorine gas is bubbled through a concentrated solution of ammonia. Another method is passing ammonia over heated metal oxide. Nitrogen is obtained on heating ammonia with a paste of bleaching powder. Alternatively, nitrogen is evolved when ammonia is burnt in an atmosphere of oxygen under contact with platinum as catalyst. Nitrogen gas is obtained by the reaction of dilute and cold nitric acid on copper metal. Heating ammonium dichromate releases nitrogen gas and a green precipitate of chromium oxide. The reaction between urea and nitrous acid also produces nitrogen gas. On heating sodium or barium azide in a vacuum, a small amount of pure nitrogen gas is obtained. Sodium azide on heating releases nitrogen gas as white fumes and sodium metal as black-colored solid. Nitrogen can be prepared industrially from air. Air in a jar is displaced by adding water into the jar. The air is then treated with sodium hydroxide to remove carbon dioxide. Then, it is treated with concentrated sulfuric acid to remove water vapor from it. The pure air is then passed over hot copper turnings in a hard glass tube. The oxygen in the air is removed as copper oxide. Nitrogen left behind in the gas jar is then collected. The setup shown here is for industrial preparation of nitrogen gas. Nitrogen gas can be prepared by this. A gas jar is half filled with air and phosphorus is burnt in it. The oxygen present in the jar combines with phosphorus to form white fumes of phosphorus pentoxide. Phosphorus pentoxide dissolves in water present inside the jar. Only nitrogen is left in the jar. Large-scale preparation of nitrogen by Linde's process is based on the Joule-Thomson effect. This effect describes that expansion of gas without work being done or transfer of heat from the surroundings is accompanied by a change in temperature of the gas. Fresh air is introduced into the system through a small hole into a region of low pressure and is compressed. Water vapors present in compressed air are removed after condensation and are removed from water receiver terminal. The dry air is again passed through the spiral-shaped copper tube which terminates in a jet. The jet expels the air into the chamber and the air expands. This cooled air moves up and further cools the air introduced into the system. The process is repeated until the cooled air liquefies to give liquid nitrogen. The liquefied air is collected at the bottom of the outer chamber and can be drawn off. The uncondensed air is again recirculated in the setup.
You saw the video for the preparation of dinitrogen. See, these reactions are very important because as I have already told you, in organic you have to memorize the reactions. They may ask you the lab preparation or they may ask you thermal decomposition methods of preparing dinitrogen. Now, dinitrogen can be prepared in the lab by treating aqueous ammonium chloride with sodium nitrite, where you get nitrogen gas, water and sodium chloride. So, that is the laboratory preparation. The next two methods are thermal decomposition. First one is with ammonium dichromate. On heating, it decomposes to form nitrogen, water and chromic oxide. Next one was barium nitride. What barium azide, you call it as azide actually. So, barium azide, you get barium and 3 nitrogen molecules. These preparations have been commonly asked children in 1 or 2 mark questions with the preparation of dinitrogen. Now, if you see the properties of dinitrogen, it is a colorless gas, does not have any odor, does not have any taste, and it is absolutely non-toxic in nature. Isotopes, because we know nitrogen, carbon, they are capable of forming isotopes. It has 2 stable isotopes, N714 and N715. Very low soluble in water, does not get mixed with water that much. It is inert at room temperature. At normal temperature, it does not react at all. It becomes inactive because of the bond enthalpy being very high, because we know dinitrogen has triple bonds. Since the bond enthalpy is very high, it does not react at room temperature, but it starts its reactivity when the temperature rises. So what happens once temperature rises, it tends to react with the metals to form covalent nitrides, like lithium and nitrogen on heating gives lithium nitride. In the Haber's process, combines with hydrogen to form ammonia, also combines with oxygen to form nitric oxide. So when we are studying the preparation, definitely we should know the properties of nitrogen also. Now we will learn about ammonia. We will see the next compound, that is ammonia. It has a molecular formula NH3, and how it is prepared. See, we know the nitrogen content is basically present in fertilizers, that is for nitrogen fixation I have told you. So this is urea having a formula NH2CONH2. So urea, when it is hydrolyzed, you get a intermediate which will be producing ammonia, water and carbon dioxide. So thereby we get ammonia prepared. The second preparation is with ammonium chloride and calcium hydroxide. This we have learnt in 10th standard, if you remember children, laboratory preparation of ammonia, where ammonia is prepared and then calcium chloride is obtained again. The third one is again Haber's process, where nitrogen combines with 3 hydrogen molecule to form ammonia. So these 3 reactions are very important. You should be learning the preparations of ammonia. Now when we come to the properties, it is a colorless gas, but definitely it has a pungent odor, because we studied that, even you have experience in the lab when I brought you, because once ammonium chloride is heated, first the ammonia gas comes out, which is being less denser, it comes out with a pungent odor, and then only the HCl gas comes out. And then ammonia having a trigonal pyramidal shape and having a good melting and boiling point as well. Highly soluble in water because capable of forming hydrogen bonds, and it has 1 lone pair and 3 bond pair, because this is the structure. It has 3 hydrogens and a lone pair here. So it has a trigonal pyramidal structure with 1 lone pair and 3 bond pair. Because of its highly solubility in water, it forms ammonium ion and hydroxide ion. So since it is soluble in water, what could it form? It can definitely combine with the ammonium salts, combine with the acids to form the ammonium salts. It combines with any acids like ferric chloride, zinc sulfate, and then it tried to form the ammonium salts as well. It also acts as a Lewis base, because Lewis base we know donates electron. Since it has got a pair of electrons, it loves to donate. So it acts as a Lewis base. And it is very useful in the organic industry for detection of metal ions. In analysis and all, it is used for the detection of metal ions. You have this salt analysis in organic chemistry. So there it combines with the copper 2 plus and it forms a complex giving deep blue color, and also with the white precipitate of silver chloride, it combines and form a colorless complex. So these are some of the reactions. These 2 reactions are very important with ammonia, as it helps to detect the presence of metal ions in the solution. Now some of the oxides of nitrogen are given in the textbook children. It is page number 172. The new textbook I am not very sure. It is in table 7.3. What you should be learning in this is name of the oxide of hydrogen, and also learn about the structure. Preparation, only 1 line is given, try to memorize it, and also the structure, not the bond parameters, at least the structure is very important, because they may ask you to draw any 2 oxides of nitrogen. So it is very important. Okay. Also you just go through the example exercise, which is the solutions are given as well in the textbook. Now we will just see about nitric acid, and with that we will stop for today. Now we have come to the last compound of nitrogen element, which is nitric acid. The chemical formula is HNO3. Now it can be prepared by treating sodium nitrite with sulfuric acid, which forms sodium bisulfate and nitric acid. The next preparation is by catalytic oxidation, which is called as Oswald process. Very important. It is a 3-step process. The first step, ammonia being catalytically oxidized to form nitric oxide. This nitric oxide will undergo oxidation again to form nitrogen dioxide. Nitrogen dioxide will be hydrolyzed further to form nitric acid. But this nitric acid is not that much percentage which is available. So to make it 100% available, you are dehydrating with concentrated sulfuric acid. So this Oswald process is very important, where ammonia undergoes a catalytic oxidation method. Properties, if you see, it's a colorless liquid, and it's a colorless liquid, and if you see, the structure has got a planar structure like this, and in aqueous solution form, this nitric acid will behave as a strong acid, which means when it is dissolved in water, also it gives cation and anion. It also acts as a strong oxidizing agent. It can oxidize metals and also non-metals. Metals like copper, when treated with nitric acid, it forms copper nitrate. But carbon, being a non-metal, also when it reacts with nitric acid, it forms carbon dioxide. So here you can see carbon getting oxidized to carbon dioxide. And the next one is a Brown ring test, which we will be doing in the lab to detect the presence of nitrate ion in the given compound, where Fe2 plus actually acts as an oxidizing agent. What happens here, children? The given nitrate ion will be there with us in the aqueous form. To that you will be adding dilute ferrous sulfate. When you add dilute ferrous sulfate, what happens is that slowly you shake it and then start adding concentrated sulfuric acid along the sides of the test tube. You will get a brown ring. There will be a brown interface between the two solutions. Such a ring will detect the presence of nitrate ion in the compound. Definitely the next lab, the next class I will be getting into the lab. I will show you the brown ring test. Then we will get into the phosphorus compound. I hope now you are able to follow this. Today we saw about nitrogen, ammonia, nitric acid, and in the table you have to learn oxides of nitrogen. So with this we will wind up the class for today, and we will meet on Tuesday with the brown ring test. Take care. Have a great day, children. Stay home. Stay safe. Bye.